Hey, statisticians! So, more notes. I told you this was a very vocab intense chapter and very information intense chapter about chapter 5, and so we're moving on to more of the same type of topics that have to do with how do I create a good experiment and how do I avoid this bias. So sampling error is something that happens within all samples just because it's impossible for me to get perfect results, especially with data that sometimes can be a little iffy. We all know those moments in class where some of you had a struggle trying to get your area of your 10 rectangles correctly. Okay, so with sampling area, I know that I want to try and avoid bias. But of course, every sample that I take, and you all took different samples of those rectangles, I will get different values, even if I took the same sample again myself, because the samples are going to vary every single time. I'm probably not going to get the same 10 rectangles if I let the hamsters choose again. And all of you let your hamsters choose, and very few of you probably had the exact same 10 rectangles when the hamsters chose. So one way to avoid, or to not avoid, but to make my sampling error get smaller is to gather a larger sample, because I'll get more accurate results. But I have to remember this. A large sample doesn't make up for if I make a crappy design and all of those issues that you wrote on the board yesterday about bias and how I might have bias in my results would contribute to poor survey design and faulty collection techniques. So some of those, of course, have to do with the interviewer, if I was doing interview, or how I construct my words, and so wording effects was one of those issues of bias. So if I collect crappy data, I'm going to have crap. And of course the question is, why am I going to all this work on collecting samples? Well, the reality is I want to be able to generalize, I want to be able to predict what's going on in the entire population. And that's very important when I'm trying to discover something new. All right, so good experimental design. First I want to talk about what are the components for experimental design. And the first thing would be the subjects. So that's the people or the units. It doesn't always have to be people, it could be animals. I suppose it could be rocks. But it's the subjects that I'm studying, the who. And then the treatment is the applied conditions. So if I was doing rocks, maybe I would be applying wind or water. So whatever it is that I'm doing that is my treatment, something that I'm interested in seeing, how does it affect the who? And then the factors are the explanatory variables, which I could have levels of. And in this particular example that I gave you, I'd like to test the effects of calcium on bone density. So I have a 500 milligram pill, a 750 milligram pill, and a 1,000 milligram pill. And I might have the subjects take it either once or twice a day. So it might look like this, where I do the once a day and versus twice a day. And so this is how I can actually figure out all of my treatments. This would be the milligrams over here. So I could have 500 milligrams once a day, 500 milligrams twice a day. I could have 750 once a day and 750 twice a day. And I could have 1,000 once a day and 1,000 twice a day. So this would be 6 different treatments that I would be testing.